Hi Caleb, this is Bhagilakshmi Varakantam. I'm recording this video of screenshot for the assignment 2, which is the linked list and the palindromes task. Stacks and task actually. So here I created the main function which calls which is this is an entry point for the execution of the task. So I have written here like a nice description of like when and which task is started. So here this is a linked list task, and here this is a check for palindromes using stack. So I have used functions to call this. This is the linked list implementation. um, I've created few more helper functions, which is to keep them in one place, which is getting the initial list, which is given in the assignment, consisting of 532148. This is the sorted list in the ascending order, and this is a reverse sorted list in the descending order. So these are the helper functions for linked list. So here I have created doubly linked list, and just like the Python code you gave in the class in the C#, we have this linked list and linked list node. So I'm using that. So here I have created a doubly linked list with the properties current node, linked list, and the functions just like you said, do, redo, undo, and few more helper functions I'll explain. So here in the constructor, I'm passing the initial list, which will add the node and sets the current node because we are the first node initially. And if you go back to the program, I'm printing the state of the list each time I do something, some sort of operation on the list. So initially this is a first list. So let me run the program first. Okay. So as you can see here, start of linked list task. So initially, I'm just creating the first node. So it's the initial is 532148, and then I'm getting the sorted list from here, and then calling the do function to add the sorted list. Here I've created the do function with the arguments of the node, the list with which the node is created at this level, and if at all I want to add some position, this is add after. A node will be passed after which the node will be added. So here it is like this. So I have this list passed to the do function, and I'm creating a node out of it, and then I'm checking if I would like to add it at a specified position after a node. So if it is null, I'm just adding it at the last, and if there is any, I'm adding it after the specified node, the new node. So at the same time, I'm setting the current node, current state of the application using this current node property, and just writing a line saying the action do is successful. So in the same way, redo is like we are going to the next task, just like you showed in the Word document. So I'm setting the current node property to current node dot next. Undo is like going back. So I'm setting the current node to current node dot previous if it exists. Otherwise, it's the end of the list with some exceptions. And each function has a line written that the action is successful, action redo is successful, action undo is successful. I've created another function called double undo, which is required like at two places in our task. So that is undo and undo, and this is to print the list, the current list. So I'm using the current node for that purpose. So initially it's just the list, and then it is sorted, and then printing the sorted list, which you can see here, and then reversing the list and then printing it, and then adding the 9 to the reverse sorted list. So as you can see here, 8, 5, 4, 3, 2, 1, 9, and double undo. So here it is like undo and undo, and then the application state is 1, 2, 3, 4, 5. So we are going from here to here, here to here, and after that to the sorted list we are adding 9. Currently the application state is this. To that list we are adding 9, and then calling the to function and printing it. So 1, 2, 3, 4, 5, 8, 9. Again double undo, undo and undo, which has to go to this, to this, and then this. So that is the linked list task. Now for palindrome, again, start of palindromes check, end of palindromes check. I have used a helper function for checking palindromes. Here I've created a static class for importing the file so that I have same kind of code in the same place, at one place. So I'm just getting the text file, reading it to the end, and returning it as string. And here I'm splitting it with comma separator, and for each one of them I'm just trimming because I was getting the space at the end or the beginning. And then I've created a class called palindromes and passing in the word and calculating the length. So I have referenced for this code internet, and you can see the references here. So I have created a public function called isPalindrome. So the logic I have used here is like until half of the first letters of the word, I'm creating a stack and comparing that stack with the rest of the word, the second half of the word. So here the helper function creates stack. So until mid length, I'm creating a stack, and then if the length is odd number, I don't have to check for the middle number, so I'm just incrementing the I here. So, and then checking for palindrome, I'm continuing the I increment. So until the length, if the word is not equal to pop, then it is not, and then like popping up, like getting each element of the stack. So if the letter at I position is not equal to the last letter of the stack here, then it returns false. Else, just increments and continues a loop until all the letters are iterated. And then if every one of them is true, it just returns true. And here you can see the result. Morning false, level true, madam true, etc. And after that, I have created a Word document for the queue problem. Let me get that. Okay. Okay, here a few problems I noticed with a remote printing system are it should be able to handle like large pool, because there would be large applications, and it should have the capability to handle such requests, and the waiting time for the printing job to complete for each person and the person's waiting in the line. By this I mean, like, let's say one of the jobs is to print large number of documents. The next jobs in line have to wait until this job is done, though they might have like fewer number of documents to print. Another problem is the jobs in the queue cannot be prioritized. They must not follow first in first out principle with the queue. The existing jobs cannot be repositioned, of course. So my solution for that would be, like, if there can be a printing system that considers the process of the time to process a job and the time a job is requested, then maybe the jobs could be prioritized based on the process time and also requested time. Then this would this might solve problems in 2, 3, and 4, which is basically related to queue. And 1, handling large pool, can be solved by some sort of like resource management. So that's all for my assignment 2. Thanks, Caleb. Bye.